Cool. All right. So here we go. So the right side might be hard to work with, even though it does look more complex. You typically should choose a more complex side. I'm just not sure how I could get cosine 4x, like how to clean up that entire right side and make it look like that. And this is something I haven't taught you guys yet, but you can break, well, I mean, well, this you should know, but why would you think to do this? I don't know why you think to do this. But you can start with that. That is true. We know that. Now, this is the part you guys are not aware of, but it will be made more clear today. So off to the side here, you guys do know the double angle formula, right? We've talked about that already. Cosine 2x equals what? Yes, that's correct. Oh, look at you. You know what's up. Yeah. So yeah, Zach knows what's going on. Okay, cosine 2x, we'll talk about today. Cosine 2x equals three different things, right? One of the things it equals is this. Yeah, go ahead, Ben.
There was a note, I think, on page 7 that said you weren't allowed to use the double angle identities for any problems.
No, but I'm just showing you how the substitution is going to work. I'm showing the derivation for it. That's what I'm doing right now. So there's this new formula I'm going to show you guys called the power reducing formula. That's what we should be using. So you want to add 1 to both sides. And then you want to divide by cosine, divide by 2. And sorry for my messy handwriting. I do want to record it. So I forgot to record on my iPad. But it's good I'm going slower because you guys can keep up. So we know this is true, right? Cosine 2x equals this. If you isolate cosine squared x, you have this expression 1 plus cos 2x squared 2. This is called the power reducing formula because what you're doing is you're taking the power, cosine's raised to the second power, and it looks really sloppy. My apologies. You're reducing it so now it's the power of 1 for cosine. So that's what I'm going to do. I'm actually going to substitute both of these here with 1 plus cos 2x over 2. And it's not an idea I fell out of the sky. We know where this came from. We know this came from the sum formula, which I will provide. And actually tomorrow afternoon, I'm going to show you kind of a flow chart, how you can actually derive all the identities with the sum difference formulas, which I will provide. So I'll provide some difference formulas. So you probably should start the test next week on Tuesday by just spending like maybe 2 or 3 minutes just deriving all the formulas, just so you have them there as a reference, and then you can just use it throughout the whole test. So that way you're not constantly driving throughout the test. But this is something that we do know. It's true.
We're allowed to like bring in a sheet of the derivative.
No. I'll provide the sum difference formulas, but you should spend the first 2 minutes of the test deriving all the formulas you need.
Okay.
Just like in the unit circle, if I give you a blank unit circle, you should like fill out, and I'll do that as well if you guys want that.
Yeah.
I'll do that. Just so you have it out of the way early, and then you could use it for the rest of the test. So anyhow, that's going to be 1 plus cos 2x over 2 times, hopefully, does that make sense how that came about in the answer key? For those who are like wondering, like, wait, what is this thing that Mr. Reed did? I didn't do the answer key, someone else did, but what is this thing that's in the answer key? That's what you're doing. So now I feel a little better about this because I have a cosine 2x on the other side. But the problem is that I gotta multiply these two and still figure out how to get a cosine 4x. So you go even more. It's like, okay, let's FOIL this. So that's 1 plus 2 cos 2x plus cos squared 2x over 4 equals the other side. So I'm feeling a little better now because if I can break apart this fraction into 3 fractions, right? That's something you have to be comfortable with too. We know how to bring several fractions down to 1. You got to do the other way around as well. How do you take a big fraction and break it down? Well, just if you have a single term, make that 1/4, 2 cosine 2x over 4, and cosine squared 2x over 4. I feel good about this, but I do see a 1/2 cos 2x. So that's good. The middle one, I feel good about. The 1/4, we'll do something to make it 3/8. This is the part that's now another nuisance. However, now I'm aware of this situation. I could do the same thing with cosine squared 2x over 4. So I have 1/4 plus 2 over 4, I know is 1/2, so 1/2 cos 2x plus 1/4 cos squared 2x. Now, this is where you have to pattern recognition. And we're going to talk about this today. So after today, you look at this problem like, oh yeah, I got this. You're good. Here's the deal. Look at this angle here. Cosine squared x equals 1 plus cosine squared 2. What if I were to double this angle? Then you would just double that angle. You totally could get away with that because what's happening is if you come back over here again, if I did cosine 4x, you'll realize it's cosine squared 2x minus 1 because if you have cosine 4x here, that's 2x plus 2x. You would wind up getting 2 cosine squared 2x minus 1. So I can simply, and I'll show you how that works today when we do some derivations. But you totally can get away with that. Yeah, you replace the 2x with 4x and you double all the angles. That's what I said. You can do that. The reason why we're going to talk about that today during class. Just wait, because I'm going to do it in the lecture, but you can do that, just so you know. I'm not saying just accept it. You should understand why. And you're asking a great question. I'll get to that in about 10 minutes. But that's something you can do. So when I come over here again, like, okay, cool. I can replace this cosine squared 2x with 1 plus cos 4x over 2. After I do that, everything should work out just fine. And I'll get the final answer. So if you look at the answer key, now let me show you the answer key because that's gonna be a little cleaner than my what I'm trying to write out. Let me clear this. I'll show you the answer key now. Did I go too far? No. Still more. Wait, I did go too far. Hold on.
It's like, yeah.
There we go. Got it. Yeah. So just to walk you through this again. Those 4x is that. Now we know this identity. It's just really a derivation of double angles, just rearrange the terms. Boiled it. Okay, cool. This part right here, goes for 2x to this. That's, I think, where there's a little bit of disconnect, right? And something else like that. How do you get that? That's because I'm using this again, but changing the angles from 2x to 4x. You're allowed to do that. I'll explain why we'll get there later in notes. Once you clean it up and combine the fractions, you should get what's on the other side. So yeah, it's a little more challenging, but once we go through what we're going to do today, you'll be fine. Audrey, you have a question?
So you just kind of use like a derivative, like those things derived, and then like if you're having a different like angle, you can just use like the ratio between them.
Right. Actually, you know what? I'll talk about it right now because I got some space here. So cosine 4x, right? That's the same thing as saying this. Cos 2x plus 2x. Yeah, I'll talk about it. It's fine. Because I'm going to do some notes anyway. Now, if you use the sum formula, which is going to be cos 2x times cos 2x minus sine 2x sine 2x. Does that make sense? Just using the formulas where you're letting u and v equal 2x, right? U and v is 2x. Now, if I go a little further, I could say that's going to be 2 sine x cos x and another 2 sine x cos x. You guys would agree? Because what's sine 2x? 2 sine x cos x, right? And I'm like writing this really small. Which is going to be minus 4 sine squared x cosine squared x. The cos 2x, we have some options for that. I can write it as 2 cosine squared x minus 1, 2 cosine squared x. Actually, wait one sec. Give me one sec here. I probably should do this. This is not terribly obvious. 2 cosine squared x minus 1 and 1 minus 2 sine squared x. Wait, should I do that? Hold on. Give me a sec here. Cosine squared x.
Focus.
Um, give me a sec here. Wait. I'm trying to prove why cosine 4x equals this. You know what? Let me come back to it later because it's in the notes. I'm messing it up. I'll come back to it later. Yeah, exactly. But it's okay. Yeah, exactly. But we'll come back to it later. Okay, guys, go back to the homework again. So my apologies. Anything else in the homework? Because we have to. So maybe just like one or two more questions. Simona and then Graham. Good. 4A, got it. All right. 4A. Let me explain it. Okay, I'll just kind of walk you through the solution key. That's probably going to be faster. Okay, so for 4A, we use the sum formula, right? So we know we'll try that. So that's x plus tan pi. And tan pi, that's just unit circle, that's 0, right? So that just goes away. So that goes away also. So you start with 1 in the bottom. So you just get tan x. So that becomes tan x. Here again, use the sum formula, that's sine x, cosine pi, blah, 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 whatever. Sine pi goes away. Cosine pi is -1. You get -2 sine x. So you get this. We're still kind of stuck here, right? The reason why I'm stuck here is that it's not factorable. So what you want to do is usually a good rule of thumb, anything that's not sine or cosine, make it sine or cosine. And then combine the fractions. So I found the LCD, which is cosine x. By doing this, I've now turned something that's factorable. Because then I can factor out sine x and make that 0, that's 0. Who cares about this, right? Because you just want the fraction equal 0. So if this is 0, that's 0, then I can solve each case. But we get stuck over here because I don't know what to do. They have two different trig functions. So that's what I would do. Or another option you could have done too. You can move the 2 sine x to the right side, change it to sine over cosine, cross multiply. And then bring there. So let me show you another process you could have done too.
Wait, how did it become pi k?
I'll explain that in a moment. But for the solution part, you could have done this, right? Tan x equals 2 sine x. Sine x or cos x. Then if you multiply both sides by cos x, you get this. And you bring everything to one side and you still get the same results. Because then you turn to a factoring situation. When we have a factoring situation, you use a zero product property. And that's what we're trying to do here. Now, to answer your question, Kath, about the pi k, well, sine x equals 0. Where does that happen? At 0 and pi, right? So you could, if you want, put 0 plus 2 pi k and pi plus 2 pi k. You totally could do that. Is that what you did? And that's fine. It's just combining it all. That's all. That's it.
So I guess a good question, but for the first one.
Oh, you're not our office, okay. Go ahead. Yeah. But he's wearing Niners. Is that Jerry Rice? Oh, you're the smartest guy now. Okay, good. And I like Kittle too. But yeah. And what's number is that? Who's that? I like McCaffrey. And was it 16 or 8?
10.
It's 10.
Who's 10? That's okay.
You have a Mac choice.
It's okay. It's all right. You didn't have like, as long as you don't have like Jake Moody or Colin Kaepernick or
You go to the game this weekend?
anyone else. So. Anyway, sorry, I digress. Yes, go ahead. Yes.
Over.
Mhm.
Oh, wait. Oh, no, never mind, sorry.
Okay. So okay question. Okay. All right. Okay. Anyway, one more question. Graham, you had one. Sorry.
Oh yeah, I was gonna ask if you could do this one, which was.
Which one?
The one we just.
Okay, and then I'll let you ask me.
Long question, but
Yeah.
for B on this one, 4B.
Yeah. Uh-huh.
Like, I
Oh.
know that sine 2x equals 0 and cosine 2x equals
Right.
-1. How come you only did the pi over 2 answer and not like 0 plus? Maybe that's
Well, so here's the thing. So sine 2x equals 0. That happens at 0 and pi. So you could do both answers. You could. It's just consolidated. That's all that's
Okay,
happening.
0 plus pi and
It's the same thing. No, it's the same thing.
I
It wouldn't matter.
Like, can you write sine two times two x as like two x plus two x, or is that not correct?
Which one?
How do you solve sine two parentheses two x?
Oh, okay. So what you do is think of this as theta.
Okay, yeah.
Which doesn't make.
So in place of theta, now you have 2x. Because we know this is true.
Two that like the sine two, like where did that two go? Not the.
Oh, no, that's just part of the double angle formula. You mean this two right here? Yeah, this is part of the double angle formula. Think of it like that, right? Which is the same thing as this.
Oh, which is like in the inside versus the outside, it's really bad. Okay.
Yeah, it's the same thing. Because we know this is true, right? Our double angle formula. Sine 2 theta.
Wait, I think I.
Right, equals 2 sine theta cos theta. We know this is true. Right. No, so then it's just theta. You're just doing the double angle formula. That's all you're doing. It's like that. That's it. Yeah. All right, guys, we do need to move on to notes. So let's go on to notes today. All right, so let's pick it up from over here. Yeah, I'll have it hand out tomorrow. Yeah, I haven't made it yet. Okay. Okay.
The test gonna be like.
I can't.
This was really weird.
We'll fall behind.
Are the test questions on
It could be one like that. We'll talk about it today. We'll talk. I'm gonna do that. Yes. I'm doing both. I'm doing both chapter 4 and chapter 5 because I did those as separate units last year. I'll give you all the stuff happened last year. All right, guys. Okay, guys, we gotta move. All right. So let's look at page 15 here. So I'm gonna jump down to power reducing identities and just kind of talk about what I already shared with you guys earlier. And this should make the homework that you did easier once you see this, right? So we know these are true now, right? We've talked about cos 2x, sine 2x. We talked about that. So cos 2x has a lot of variations. 1 minus 2 sine squared x, 2 cosine squared x minus 1. So what if I rearrange this? What if I move the 2 sine squared x to the left side and that cos 2x to the right side? I'd have this, right? Then divide by 2.
But you have to divide by -2.
Why? I moved it around so I avoided that. I want to avoid that. So I deliberately moved. I know why. Because you didn't see my first step. That's okay. But I've moved the 2 sine squared to the left side to avoid dividing by -2. Because I just want to keep it just positive 2 on the bottom. So that right there is called the power reducing identity because you've taken sine squared and reduced the power to another trig function with a power of 1. See on the right side, the power of the trig function cosine 2x is the power of 1. Whereas on the left side, the power is 2. This gives you a little more flexibility when solving trig equations because it's kind of hard to solve a trig equation when something's raised to another power. So if you had sine squared x, you could do that. And then, of course, you could solve it afterwards because then you could do the inverse cosine. So it just gives you a little more flexibility. Likewise here, let's move the 1 to the left side. So you have this. And you have 2 cosine squared x, and then, of course, divide by 2. So we have another identity. If you see a cosine squared x, which we had in the homework that I talked about, number 6, that's the thing you can do to substitute. So it makes life a little easier when you deal with those kind of problems. Then before I show you tan squared x, any question on how I did that? Again, just take what we already built, where we know, we're building on top of it. That's what we're doing. Anyone have an idea how I do tan squared x? Now I have this thing for sine squared and cosine squared.
You put them over each other.
Good, thank you so much. Yes, see? You guys are just building on top of what you know. Good, awesome, yes. That's great. Because we know this is true. Yeah, so what you're gonna do is you're gonna divide this. Yes, see, yeah, good. Now things are clicking. Good. Yeah, because we know tan, sine, and cosine. So if I square it, what to do? So sine squared and cosine squared. So I got this divided by this. These are two fractions. When you divide fractions, what do you do to the fraction divided by? You
Flip it.
flip it. You flip it, the twos cancel. The twos cancel. You should just get this. And I'll just kind of sit on this for a little bit so you guys can fully see all the mechanics that happened here. So that's what's happening, right? So that's yet another identity we have that we can use. Again, I'm only providing some different formulas, but we'll practice tomorrow. Hey, start with that, and let's go through the flow of like how I get all these other identities.
So that's at the very end, which has to be also derived these ones.
Yep, 100%. Yeah. Yep. It's essentially you're gonna do this. Some difference formula to double angle the power reducing, and then there's another one we're gonna talk about power reducing the half angle.
There's one.
Oh, yeah, there's one more we're gonna do after this. Yeah. Yeah, you'll see.
Is that in 4C?
Correct. So they're all summarized right here. So now we're going to look at pattern recognition, right? So if that's a 2x, of course, that's going to be, yes, yeah, because look at the pattern, right? X, 2x, X, 2x, X, 2x, 2x. So if you see a 2x, that's a 4x. You see a 3x, what are those going to be? 6x. You see an x over 2, and that's going to be something called a half angle identity, which we'll talk about in a little bit. Yeah, it totally would make sense. So essentially what you're doing is you're looking at the pattern here. Like, see how that angle double this? So naturally this has to double this. This is double this. Exactly correct. Right.
Yeah.
That's all happening. Right. Because I'm doubling the angle. Because I look at the pattern. Double this. This is double this. 2x. Yeah, all right. Good, all right. So now, this is your chance at, guys, your chance at redemption. All right, your chance at redemption. You can now, it's not exact, it's not quite the one that we had on the homework, but it's pretty close. All right. Okay, I'm gonna have you guys try this.
If it's 2x, 4x, I get the same for all the different identities.
Right.
Seven on the 10th.
Yeah.
I'll do a variation.
Nothing changed.
We'll see if you can do it. See if you can handle it. Can you handle it?
No.
Do it. Show me. Do it. Okay. I'll give you guys a chance to work on it. I'm gonna freeze the screen and pull up the answer key because I'm feeling kind of lazy right now. Because I have the answer key. But I'll give you guys a chance, a few minutes to work through. I'll walk around. But it's very similar to the homework, okay? But I gave you a little push, start with the left side. Sine squared x times sine squared x. What was that?
We allowed to do the right side.
You can if you want. It's up to you. If you want to do it, go ahead. Actually, I'd like to see that. So you can. On the homework? You can. Actually, can I see it? Right side? Okay. I guess just the left side, just so you practice using the new identity, so.
You curve.
I might, if I have to, I will, but hold on, you guys haven't seen the test, I haven't even made it yet. Totally pull the cart for the horse.
No, but he got extra credit on the test.
I do have.
That's how people got 101%.
I do have three conditions.
Oh, yeah.
The average is low. Yes.
Hello, please, can we?
Below 80%.
Ben gets 100%, can we see if everyone gets below 80%?
No one gets 100%.
Last year, he literally got 100%.
And it's too long.
Like, got.
That means I wrote the hard test.
Everyone's
Everyone.
They make action test extra credit.
Is everyone like?
Yeah, good idea. I like it. Whole test.
Okay, just an outlier.
Optional.
If you get an outlier,
Above and beyond.
I'll run through that.
Yeah, like above that.
This guy.
It's negative, like, he's like paying attention. He just said, "Oh, no, I'm not catching straight." No, he's catching straight.
I think like 3 classes now.
Right now, it's okay, she was getting back.
You guys do it.
It's not science. Oh, yeah. I got to know. I know.
You also.
Wait, if anyone solved it, I'm like,
I got you. I don't know. Exact same thing. The exact same. You don't
He
think.
saw the steps, which is good. Yeah.
No, but I heard
Okay, so listen. Let's audio. We can figure out
Okay, I'll give you guys about 2 or 3 more minutes. We have to move on to the next part of notes. Yeah, guys, stop. Let's get focused here.
Got it.
Yeah, he said that word and no one laughed except for me, and I really felt. I really felt young.
It's very, I got it, but I don't never ever. What was the word?
You got it?
Yeah, but I never worked on this.
Yeah, now you do. Now you do. Now you know.
Good homework for after this.
Yeah, I know. The homework would be easier now. I get it. Yeah. All right, let me show you guys the answers. Okay. If you send work on the left side. Okay, can I get everyone's attention? All right. I got this. 1 minus plus 6 over 2, 1 minus plus 7 over 2. Great. What we got? So you work it all out. Here you go, cosine squared 2x. Now we know that if it changes 1 plus 4x, so 2.
How do I know that?
Because what we just did earlier.
Not that you just right.
Over here. Really got it.
Okay.
That's 2x, 2x, 4x. That's 2x, 3x, 6x, x, 2x, 2x, x over 2x. It always knows that this is double this. It's angle, not angle. So this is double this.
Why?
Yeah, I mean, that's it.
So coming back to this. So coming back to the solutions. Coming back to the solution again.
Yeah, for the final.
So first of all, I see where that says. Power resistance. What the power resistance is? Like boils it like this, right? No, this here goes to this. This is some of this. That's the confidence. That's the rest.
Like, what is this equal?
Multiply. All right.
Okay, that's
enough.
Yeah. Oh.
Yeah, that makes sense.
Yeah.
And that was me, you're supposed to.
Okay.
Oh. Wait, thanks for.
Hey guys, questions before I move forward?
There's one in the bag.
Good. I'll put on a test then.
Oh,
Yeah.
exactly.
No, I'll do a variation of it. Okay, good.
Dash number.
Yeah, sure.
Don't make it like Tan's.
Oh, actually, that's a good one. I'll do that. Yeah, thanks for the idea. Audrey just gave me a good idea. All right. Okay. I'm just kidding. All right.
You got one.
Wait, this phone is really hard. They should give this.
All right. Hey guys, I need you to quiet down. All right. I know you guys get excited. It's good. It's time for math. All right. So we're gonna skip a bunch of pages because this is repetitive. So it doesn't show up on your end, I think, or maybe it did. I don't know. It does, yes. Okay. So let's jump to half angle identity. So half angle is an extension of what we just did. So it's the last identity we talked about. It's on page 20. This, and there's a word problem we're gonna do, and then we're done. You'll see. Sinusoidal, yep. All right, okay, you guys ready? Guys, let me talk. Thank you. 17, 20. My bad, 20. Okay, so remember we had a power reducing identity for sine squared x. Sine squared x, if I rewrite it again, is the same thing as saying this, right? We know it's 1 minus cos 2x. I'm just repeating what we did about a few minutes ago, right? Now, I could then rewrite it like this. It's like a U sub in a way, if you think about it.
Oh. Oh, what sound?
A U sub?
Oh, yeah.
Like for example, like you don't have to write this down, but like say I gave you something like this here.
Precalc AB.
I hear stuff like.
They do some of this, yeah, they do.
Later on.
Yeah.
I can't remember.
Okay, so but like when I talk about U sub, just so you guys know what I'm talking about, like we have x at 4 minus x minus 12 equals 0. You treat that like a quadratic, make it u squared minus u minus 12, and it'd be u minus 4, u plus 3. It's kind of the same thing I'm doing here. I'm just replacing x with x over 2. So if that's the case, then this becomes what?
Cosine.
Cosine x, right? Good.
Wait, so it's just the same thing, but
Wait, can you explain that one more time, please?
All I'm doing is I'm replacing x with, or think like this. I'm like you guys, let me explain. Let u equal 2x. If u equals 2x, then x would equal
Wait,
4x.
what is you?
look, it's just a random letter. It's just a substitution. You know what? Forget about this u sub thing. The bottom line is just know the pattern. This is half of this. This is half of this.
Wait, no,
So
but
that's all.
wait, the use of things, wait, so that means if it's
Right.
sine 4x, that means you put in 4, so it's 4 times 2 is 8, so it's 8x.
Correct.
Okay.
Correct. Correct.
Wait.
Yeah, what? It's just.
Here. Here, guys. Set this equal to u. X equals u over 2. So you put u over 2 here, and you put a u there. It's the same thing. That's all. It's the same thing. Yeah, that's all we're doing. Okay, so let me finish. So then, if you square root both sides, you get that, and that's a half angle identity. Now, as a plus or minus, because you're square rooting to solve for another variable expression. Now, how do you know which one to use? Is the positive or negative? It all depends on what angle you're looking at and what quadrant you're in. And of course, if you're doing like a sine of something in the third quadrant, make it negative. If you're doing the cosine of something in the fourth quadrant, make it positive. It all depends what you have. The tangent does have a couple of variations. What you could do is you could do the conjugate. If you multiply top and bottom by like root whatever, like if you multiply time by root 1 minus cos x, you could get you can get this variation, or you get the other variation. So it just depends on what you're working with. Okay, Graham, sorry. Thank you, patience.
That every time you have a squared and then like some sort of multiplication of x in those parentheses, all you need to do is multiply 2x by whatever
Correct.
is in those parentheses.
Yes.
So that's just his blanket rule, even if it's like
Yes.
a fraction or a
Yes.
base number.
Yes.
Okay.
Right. Like if I had like 4.5x, I put 9x.
Yeah.
Yeah, there we go. Someone good?
So just to clarify, when do you, like, how do you know when to use plus or minus again?
We're gonna do it right now.
Oh.
I'll explain. Let's do an example. So let's take a look at A and B for example 6. Audrey, go ahead. Yeah. No, go ahead. Go ahead. No, that's fine. It's fine. I didn't see your hand. Yeah. No, we're not solving. We're evaluating. We're not solving. The extraneous solution is more like just plug back in the original. That's if you're squaring both sides to solve an equation. We're not solving equations here. We're just evaluating. So sine pi over 8. So the problem here is if you're asked to find the exact value, like pi over 12, I knew to do 4 pi over 12 minus 3 pi over 12, right? And 4 pi over 12 is pi over 3, 3 pi over 12 is pi over 4. You're good there, right? Pi over 8, I can't really subtract or add angles to get pi over 8. But what I could do is think of theta as pi over 4. Because what's half of pi over 4? Pi over 8. So what I'm going to do is this. I'm going to do sine of pi over 4 over 2 will equal plus or minus. I'm just plugging into the formula. 1 minus cos pi over 4 all over 2. Now, this part's a little tricky, and I'll explain why in a moment. That's 2. Apologies. Do better. Here we go. And I'll leave my answer like that. So that's going to be the exact form of sine pi over 8. Now, why did I drop the plus or minus, and how come I didn't put a negative? Why put the positive? Think about it. Pi over 8. What quadrant is pi over 8 going to be in?
First.
So keep it positive.
Mhm.
Okay. What if it was like 11 pi over 8? Then 11 pi over 8 is the third, so it's got to be negative. Right. All depends what you're working with. All depends what you're working with.
Wait, and are you dead set on not giving us any of these formulas?
Yes.
Well, just like the 2x ones, I feel like would be helpful. Just because we can barely solve the problems, or I can barely solve the problems.
Either screen, this is a whole class thing. It's like.
Except for
Except
survey.
that, let's exclude.
Guys, let's go to.
Except you two. All right. Okay. Theta. Okay, guys, let's move on. The more you argue, you're just wasting your breath. Yes, there we go. Okay. So I'm gonna let theta equal 7 pi over 6. Now you could use a sum formula and do 3 pi over 12 plus 4 pi over 12. You could do that. But just to show you another option, what if your angle 7 pi over 6? Because what's half of 7 pi over 6? 7 pi over 12. Now, 7 pi over 12, what quadrant would 7 pi over 12 be in? Correct. Because 6 pi over 12 is pi over 2, and that's right on the border. So now you're gonna be in the second quadrant. So I'm gonna make it a negative angle. Sorry, a negative answer. Sorry, say again?
You can use the sum formula for all these questions.
Not for pi over 8 though. Actually, no, yeah. How would you do pi over 8? Yeah, you can't. Yeah, no, because of the ones that you know, pi over 6 or pi over 3 or pi over 4 or pi over 2. I can't get pi over 8. That wouldn't work. Yeah. So you'd have to do half angle in that case. Maybe. Well, pi over 12. Yeah, you could. Yeah, you could. You could. So this is gonna be 1 plus, guys, quiet. Thank you.
Are we assuming that the 7/12 became the 7/6?
Correct.
Okay.
Like federal solutions, but the city, what am I doing?
Okay, and then when I just finish it off, that'll be negative radical 1 plus, and cosine 7/6.
Negative.
It's plus root 3 over 2, negative root 3 over 2.
Yeah.
Yeah, correct. So actually, I'm going to make it minus root 3 over 2.
Where did we get this? Where did we get out? Yeah, where did we get this plus?
Cosine 7. Give me a circle. Cosine 7/6 is negative. Plus negative root 3 over 2. I don't care.
Oh, wait, I'm sorry, I was. What? Oh, it's
It's like very over. Wait,
Wait, but how does it, wait, what's the answer?
Yeah.
You just look at.
Well, sorry, what are you asking about exactly? Are you asking about the negative on the outside or negative on the inside? Well, what negative are you asking about? Okay, that's because 7/12 is in Q2. 7/12 is more than half pi, because 7/12 is more than half. So you have to be in Q2, and you're doing cosine, so cosine's negative there, right? Then on the inside, cosine 7/6, that's negative root 3 over 2. So you can write 1 plus negative root 3 over 2, or just 1 minus root 3 over 2. Same thing, won't matter. So, okay. So let's do one solving, and then we'll do the word problems I'm going to talk about, and then we should wrap up right before class gets out.
Wait, where is?
Okay. It's right at the end. Sinusoidal. Yep. Okay, here we go, guys. All right. So what? Okay, guys, can I keep going? Thanks. Awesome. All right. So I'm gonna do this first. We'll do example 7a. We won't do B. I didn't do it the other class, so that's all good. Cosine squared x, so cosine squared of x over 2. So I'm gonna write like this. Just so I don't skip any steps, so everyone knows what I'm doing. Hope you know what I'm doing. All right, okay, yeah, got this right. And we have a formula for this now. Well, that's plus or minus radical 1 plus cos x over 2 squared. And on the left side, I'm going to do this. Oh, look at that. Yes, Bill's AI powered. A little bit. Oh, well, when the weather gets a little warm, it closes them and opens them. So, okay, so hopefully you guys can see I did some substitution, right? Things that we should know. Sine squared x, you should know that. Value tree identity. This new stuff. So cosine squared, put the square on the outside, you have cosine x over 2, you have that. So far that seems okay. Okay, I'm gonna have you guys solve out the rest. Solve out the rest. I'll show you the answer in a couple minutes. But when you square plus or minus, it won't matter because it just goes away. You square the radical, it also goes away. And now everything in terms of one trig function, it's going to become, I think, some sort of quadratic situation that you guys can solve.
So
Okay, so work it out. Tell me what you get. I'll work it out too. We'll compare. Ben, you got it? Or you had your hand raised? Oh, I thought your hand raised. Okay.
Wait, this is not bad.
Well, thank you. I think so too.
This is my brain, so this is like if you did it. Like, thank God.
Yeah, I did, and I don't think I already answered that, I'm already solved it. Oh, no.
Have to become a plus because you're squaring.
Correct.
Where do you go? To the L squared stuff. Sorry, I mean, should be forgetting about. Yeah, right.
Graham, how do you not skip a step and figure like having other hard problems?
We can lay off
Like,
Graham.
shit. I'm just curious, like, it's actually.
Okay, I figured it out.
do we need to find a general solution for this?
Yeah, you do.
I know. Thing.
You guys should get 3 answers in the first rotation of the unit circle.
Yes.
Yep. Okay. Do you like this problem?
Like,
Okay.
I would like know what to do.
Yeah, if you guys done the first
Yeah, if you guys
two
done
steps,
two
I would've
steps, I
known.
wouldn't have known it. But
Yeah, but now we know that the half angle formula.
It's like
Yeah.
something squared and put squared out.
Oh, that's always a thing because that's a shorthand notation for squaring trig functions. It's the same thing. It's the same thing as putting parentheses cosine x squared on the outside or cosine squared x. They're the same thing. Yeah, actually, let me make sure I was clear on that because I'm glad you brought that up, Simona. Hey guys, you guys are clear on this, right? If you have cosine squared x, you guys are aware it's the same thing as cosine x parentheses squared. Yeah, it's the same thing. So just make sure you're aware of that because it's just a shorthand notation, just so you know. Okay. Yeah, so that's what we get. And then of course put plus 2 pi k. Just to be on the safe side, you guys should actually check your work. So it's gonna be okay. Because sine pi over 2 is 0, or 3 pi over 2 is 0. So that's 2 on the left side. Here, if I take half of pi over 2 is pi over 4. Cosine pi over 4 is root 2 over 2 pi squared becomes 2/4, which is 1/2. And it's still gonna be okay. So it's still not gonna be a problem. So we'll still be okay. So
Wait, mystery, can you build in time during the test to check answers?
Can you also build in time for us to like write these equations? Cause I feel like those will take me like to
fine.
derive.
yeah, no, when I go through it myself, I will.
Okay.
Yeah. Well, I'm just checking some math real fast. Yeah, actually, sorry, let's say sine pi over 2 is 1. My apologies, but it works.
I have a question.
Both sides will work. So
You know, like cosine x equals 0, obviously, because of the factor thing.
Yeah.
Right?
Mhm.
How come you only did 0 and not pi? Is that what?
because cosine pi is -1.
Oh, yeah.
Yeah.
What if I got that cosine is equal to -1? What if?
No, it's
Yeah.
positive.
You just did it wrong. My gosh, you very much.
You made a curious mistake. All right, last thing, guys. Sinusoidal. All right, we're gonna jump. Okay, guys, we got 7 to 8 minutes. I got one more problem to do, and we'll do more of this tomorrow because tomorrow I still want to kind of tie up some loose ends, and then use tomorrow for review and practicing like how to derive the formulas and other practice problems. And I will produce all the old tests from last year, other stuff. Okay, if you guys go to page 24. Okay, and give my voice a little break. And we'll let the most vocal person read. Sorry, you're the most vocal person today. I've been here looking at you. So, well, just read for me, please. There's another story earlier on, but go ahead. Yeah. Okay.
What's his name?
Here, we'll name it after you. I want to. Okay. No. Okay, you name it. You name it. Okay. Okay, keep going. All right, go ahead. Okay, let her read. Let her read. Okay, good.
So you start a stopwatch and start monitoring its body temperature. Notice when the temperature varies. Side use soil leaving.
Get out there.
Want me to read it?
Go.
Here.
Wait, what do you mean?
It's a story from a previous problem. That's all. Yeah. Sophie, why don't you open up your email? Okay, I'm just gonna do the problem now. Sorry, that was a bad choice to ask her to read. But probably Mr. Ray's. Cause I co-taught pre-cal. This came from pre-cal AV honors like 13 years ago. Yeah, when I taught pre-cal AV honors. Okay, there's a story in the previous problem, but I didn't like this problem. I like this problem a little better. So here's what we're gonna do. We're gonna model the situation as a sine function. Okay, we're gonna model the situation as a sine function. So what I'm gonna do, just like you guys have modeled like in physics, like parabolic motion, if you throw something over a cliff and you're looking at that, or if you're looking at linear regression, any kind of problem that involves any kind of real life scenario, we're using an equation to model the situation. That's what we're gonna do. So we're gonna do a quick graph. We're gonna let time be x. So time will be x. Oh, I'm frozen. Here we go. There we go. Thank you. So time will be in minutes, of course. We'll let temperature be y. That will be in degrees Fahrenheit. And you're told, well, sorry, I was like being hysterical. At 35 minutes, that was the lowest temperature. Okay. So that would be a low point of the sine curve. Because sine curves have low points and high points. We know this. 30 minutes later, the temperature spikes to what? So that's going to be the high point at 105. Graham, you had a question.
Yeah, how did you determine to graph it as a sine curve? Was there something that
Sinusoidally.
Because you told it. You're told so. That's why. And by the way, you can do it as a cosine curve too. You don't have to do this. I'm going to do sine. Just
Would it be like cosodial?
no. It's still cosinusoidally because cosine is a complement of sine. They follow the same shape. That's why. So we just generally call it that. It's the same thing. Sinusoidally.
What is cosine? To the answer, but.
Let me finish the problem first, and I'll clear it up in a moment. Okay. Now, if you think about it, another 30 minutes later, it has to get back to the low point, right? Which would be 95. So this is a repeating pattern, right? And by the way, at 5 minutes, has to hit a high point. Okay, I didn't quite do the scale, but it's okay. So we expect the model to look like this. Temperature goes up and down, right? Like that. Okay. So your goal is to write an equation for that graph. We've done that before, actually, in other problems, but now we're doing the context of a word problem. Your goal is to write an equation for that graph and then answer the other questions based upon that equation. Now, when you write an equation, actually, I'll just do a portion of this. Here we go. When you write an equation, we know generally sine looks like this, right? A times sine bracket B x minus h plus k. What's my amplitude? Not quite. 2. Because the middle, where's the middle? 1 and 3. So you're going 2 up and 2 down. So your amplitude is 2. Okay. Actually, let's get k out of the way. What's my middle? 103. That's middle temperature. We'll worry about h in a moment. Now the period, how long is one cycle? Yeah, because half a cycle is 30, so 60 minutes. So, but no, b is not 60 though. 2 pi over b equals 60, because we know that to be the form for period. So your b value is pi over 30. And then finally, if I'm writing this as a sine graph, now you could do this as a cosine graph too. It's up to you. But if I write as a sine graph, I'll start over here. That's where I'll start. If I'm going to start there, that'd be 50 exactly. Now, to answer your question, Arav, like cosine. If I want to do as a cosine, where would I start if I start as a cosine?
At the high.
Which is what?
5.
You can do 5 or 65, up to
It
you.
would be right either way.
Yeah, it would be fine. Mhm.
I don't know.
So y will equal 2 times sine. I can send next 30 seconds. This is where I left the last class. With all distractions, we still actually got to the same place, which is amazing.
Wait, what is 60 again? You
The
shift?
period. Period of graph, yeah. No, appears never b. B is the constant.
Period equals 2 pi divided by b.
It appears 2 pi over b. The shift, right? Now, I'm not gonna have time to go over the other parts, but we'll talk about tomorrow. Now you have an equation. You can put 120 to get the temperature to go at 120, or this is why I need to talk to Mr. Morris about who was here earlier. I might throw in instead of using graphic calculator, I might have a Desmos built in as part of the test, because I think you guys could do a lockdown browser with Fuji. And yeah, let me think about that. But you could also graph 1.4.5 and see where it touches the curve. We'll talk about this tomorrow. Oh, one last thing. So this is what we just did. These are practice problems on that. It's important.
One question.
Yeah.
It's like drawing, it's like writing equation.
Yeah,
That's why I was like forcing vectors.
Oh, I thought it was gonna be a formula.
That's what I thought, exactly.
So-
Okay, I know some body diagrams and like I feel like a decimal, like it makes sense because I made my. I don't know which estimate it was, Zeta or Dad. But one time, dot, and then they did like mass drilling behind the dot and then like, and then Mr. Franken was like, so actually the dot is enough, so you just got extra mass over here, and then like you have your vertical forces, he was like, yeah. And then he like going over it, he was like, I don't think it's wrong. I get so excited. What else do you know? You got to see first. Oh,
I didn't get from Iowa. It's not crazy. I'm like I was going to the basketball sport. I tried going back and revise like but it was
It's okay. I like thought that graph.
Yeah, but-
Found like the like
Oh, that's like, I'll get
the
it.
graph for some reason. Yeah.
Yeah, so everyone did, it's like so hard.
Got this up. Yeah.
How should I?